All right, our next scientist is Joseph Gay-Lussac. So the two variables that Joseph Gay-Lussac studied were pressure and temperature. So pressure and temperature. So if he studied pressure and temperature, what two things did he keep the same? Well, he kept the moles, which is the amount of gas, and volume. So maybe the container can't change its shape at all, so you can't do that. So what if you were to increase, so notice here we're at 200 Kelvin and we're making it hotter, but it's held in place. So if it gets hotter, those molecules are going to be moving faster, so the pressure is going to build up. Normally they would like to expand, but if they can't expand, the pressure would build up. So this is a direct proportion again. So this is direct proportion. So they are directly related. So that means if the temperature goes up, the pressure goes up. If the temperature goes down, the pressure goes down. Good example. Have you ever used the compressed air to clean like your keyboard? So you're releasing some of that one's probably not a good example because you're changing the moles. Anyway, I was just pointing out that can gets really, really cold, but you are changing the amount. So you got a lot of variables going on in that one. All right, so let's just look at the formula then. If it's pressure and temperature and it's a direct proportion, anytime it's a direct proportion, it's going to be like a fraction, and P is on top and T is on bottom. P is on top and T is on bottom. So just like in the combined gas law, we're just taking out the part of the combined gas law we don't need. All right, so pressure and temperature. So if you want to pause the video and see if you can get this one right. A lot of students miss this one because this one has a catch to it. So if you want to pause, see if you can get it right, I'm going to continue working. This question is asking for our temperature to be in Celsius when we find it. So please watch that on your test. It says a cylinder of gas has a pressure of 4.4 atmospheres, and we're currently at a temperature of 25 degrees Celsius. Now it's going to ask for it to come back in Celsius. You can't leave it in Celsius. You have to use, when you're using any of these gas laws, we've got to add that 273. So this is 298. You must do that. Must be in Kelvin. So they're not mentioning that, but we are changing that pressure. So we are making it more pressure. So we see that pressure going up. We should see that temperature also go up, right? So also go up. And so we are looking for temperature. So please try this one. A lot of students miss this one because what we're looking for is on bottom, and students do have trouble when your X is on bottom. So I'm going to cross multiply so I don't have trouble with this. So 4.40 atm, and my temperature is 298. And I'm changing that pressure, and I'm looking for my temperature here. So my X is on bottom. This time I'm going to multiply these two variables, and I'm going to end up dividing by the 440 because that's going to be what with X. So I'm going to multiply 298. That should have been a multiplication sign. Let me get that off of there. And we're going to multiply that by 6.50, and then we're going to divide by that 4.40. So once I do the math here, I'm going to get an answer of 440 Kelvin. It's coming out in Kelvin because this is Kelvin. The question asked for it to be in Celsius, so now I need to subtract that 273 to get a temperature of 167. Okay, so a little catch to that. So please watch that. Don't ever use, if you put 25 here, you're not going to get 167. It will not work in Celsius. All right, that is Gay-Lussac.